Students, we are back talking about solutions, a very long chapter. I know we're over halfway done now, though, so stick with me. Now we're going to talk about another way to calculate concentration called molarity. In the last video, we learned about mass percent, and I know I didn't spend a lot of time on mass percent, but it is very important. Expect to see that on your exam and on the final, perhaps. So do really learn how to do mass percent calculations. Also, molarity is very important as well. You do need to learn how to do molarity calculations because you will see that on your next exam and probably your final. So molarity is another way to measure concentration. Molarity can be symbolized with a capital M, and it stands for moles of solute over liters of the solution. And it is on the back of your periodic table on the shapes table right there. So you will always have access to this to see what the formula is for molarity and mass percent. So moles of the solute, the ingredient that there's less of in the solution, over the volume of the solution in liters, moles per liter. So a solution that is 0.250 molar contains 0.250 moles of solute in 1 liter of solution. Here's an example calculation. Calculate the molarity of a solution if 9.99 grams of potassium bromide is dissolved in water to make 2.50 liters of solution. Excellent. We're finding molarity. We need moles of solute over liters of solution. I see we have liters of solution, but we do not have the moles of the solute. The solute is potassium bromide. We need to know what that is. What is potassium? I hope you said K. What does bromide stand for? I hope you said Br. Now we need to put those together by checking the charges. Potassium is in column 1, so it has a +1 charge. Br is under fluorine over here on the nonmetal side and has a -1 charge. So we have a +1, -1. So those come together and the formula will be KBr, not KBr2, KBr. Excellent. We have grams of KBr, but we need moles because it's molarity and that has moles right in it, right? We need moles. How do we go between grams and moles? Well, we worked on this a couple of chapters ago. You go between grams and moles by using your periodic tables mass, the molar mass. Excellent. So again, molarity, capital M, is moles of solute per liter of solution. That's on your periodic table on the back. We need to convert from grams to moles. So 9.99 grams of KBr. When we add up from our periodic table 1K and 1Br, we get 119.00 grams KBr in 1 mole. Grams is on the bottom, so it'll cancel out. Grams cancels out. We're left with moles. We get 0.08395 moles KBr. I'm keeping an extra sig fig because this is not my final answer. So keep extra digits or just keep it in your calculator. Now that we have the moles of solute, we can divide by the liters of solution. So molarity M equals 0.08395 moles of KBr divided by 2.50 liters of solution, and that equals 0.0336. Capital M can be the unit or moles per liter. 3 sig figs in our final answer. The 3, the 3, the 6 are the sig figs because everything we started with was 3 sig figs. So 3 sig figs in our final answer. All right, so this is a typical molarity problem. I know that was pretty quick. You've got to be able to do this. Take your grams, convert to moles, then divide your moles by liters of solution. Okay, again, practice more of these from your end of chapter problems and the worksheet. Next is dilution. So, sometimes a more concentrated solution needs to be diluted to a new concentration. When diluting a solution, the number of moles of solute does not change. Okay, all we're doing is adding solvent, which dilutes the solution. It's like if you had a bunch of ping pong balls in a bathtub and then you added more water. It doesn't change the number of ping pong balls in the bathtub. All you did is add more water, and so it's more dilute. Okay, that's what we do when we dilute something. We add solvent, not solute. We add solvent and dilute the solution so the concentration goes down. Because the number of moles remains the same and only the volume and the concentration molarity changes, we have a formula we can use. M1V1 equals M2V2. And guess what? This is on the periodic table as well. M1V1 equals M2V2. M1 is the original or initial solution molarity. V1 is the original or initial volume. M2 is the diluted or final molarity. V2 is the diluted or final solution volume. M1V1 equals M2V2. All right, so we're going to use some algebra skills here, right? We got some algebra coming up. Let's try an example. What is the molarity of a solution that is prepared by diluting, there's your key word, diluting, 50.0 milliliters of a 6.0 molar NaOH solution to a final volume of 110.4 milliliters? So diluting, final volume, we have an initial volume and a concentration. So yeah, we're going to use M1V1 equals M2V2. Let's just identify the variables. The initial molarity is 6.0. The initial volume is 50.0 milliliters. The final volume is not known. That's our unknown, question mark. The final volume is 110.4 milliliters. So note, the concentration and volumes must be the same unit. In other words, both volumes have to be in the same unit. Here they are both milliliters. And the concentrations both have to be in molarity. Okay, so then we can use M1V1 equals M2V2. So let's plug this in. So again, we have 6.0 molar times 50.0 milliliters equals M2 times 110.4 milliliters. Now, how are we going to solve for M2? Well, we're going to divide both sides by 110.4. So M2 will equal 6.0 times 50.0 over 110.4. Punch that into your calculators. Pay attention to sig figs. Go with the least. And we get 2.7 moles per liter. Capital M is moles per liter. That's a molarity. Did it go down? We diluted it, so the solution concentration should go down. Well, it started at 6.0 moles per liter. Now it's 2.7 moles per liter. So yes, it went down. Good job doing a dilution calculation. We're going to do one more. I want you to hit pause and solve this on your own. How many liters of a 12.0 molar HCl solution is needed to prepare 0.750 liters of a 1.45 molar HCl solution? Hit pause. Try this one. Okay, we're back. This time it's the liters we don't know. How many liters of a 12 molar HCl solution? That's really concentrated. So we're going to use M1V1 equals M2V2. M1 is 12 molar. V1 is unknown. M2 is 1.45 molar. V2 is 0.750 liters. So we're solving for V1. Let's plug in. We have 12.0 molar times V1 equals 1.45 molar times 0.750 liters. How do we solve for V1? We divide both sides by 12.0. There's V1. Punch it into your calculators. Pay attention to sig figs. I think everything has 3 sig figs this time. And we get 0.0906 liters. 3 sig figs. Zeros in front do not count as sig figs. So that has 3 sig figs. All right, good job with your dilution calculations. Let's take a break. Catch you in the next video. Bye-bye.